Good morning. This lesson is for my Honors Integrated 1 class. This is a Unit 5 Quiz 1 review. But before I get started, I want to say that I hope everyone is doing all right out there. So let's just go ahead and jump right in. I wrote what I would call a flow chart, and that tells us the process and how to solve systems of equations using elimination. And so what it is the very first thing you're going to try to do is you're going to try to add equations together. If you can and somebody cancels an x value or y value, proceed. If you can't, you're going to subtract. And what that means is you change the signs of all the numbers in the equation. You might want to write that down on this flow chart. So if you can get a variable to cancel by changing all the signs, proceed. If you can't, what you're going to need to do is you're going to need to multiply one equation. Okay? Or try to multiply one equation. Now, if that works, go ahead and proceed in adding them together and get someone to cancel and solve for the other variable. If multiplying one equation doesn't work, you're going to need to multiply both equations by a number to get somebody to cancel. So let's see here. I'm going to just go through this process and show you how this works. All right, so problem one. Can I add these equations together and get an x value or y value cancel? And yes, I can. So what I'm going to do is I'm going to proceed. So minus x, which is minus 1x, plus 5x, is going to give me 4x. The y's cancel out, and I'm left with 4x is equal to 4. I can divide away my x, I can divide away my 4, and I'm left with x is equal to 1. So what I'm going to do now is I'm going to plug this x into either equation, and I'm going to find my value for y. I like the first equation, so it's going to be minus, I'm going to put a parentheses for my x, minus y equals 1. I'm going to put a 1 in here, that's what the x was equal to, and I have minus 1 minus y equals 1. I'm going to add 1 to both sides to cancel that out, and now I'm left with minus y equals 2, and I need to divide away the negative, so divide that away. And I get y is equal to negative 2. So the answer to my first system of equations, it's where the lines cross, and it has to be written as an ordered pair. 1 comma negative 2. Okay, that's the first problem on your practice quiz. Let's move on and look at the second problem of our practice quiz. And again, I'm going to follow this flow chart. Will somebody cancel if I add them together? The x's won't cancel and the y's don't cancel. So I'm going to go to the second one. Can I change the signs of all the numbers in one equation and add them together? If this is positive, it doesn't cancel. If this is negative, it doesn't cancel. So I can't do that. So now I move on to the third possibility, and that's to multiply one equation. And so I'm going to look at this piece by piece. Can I multiply 2 by a number so it cancels that? Not a whole number, but you technically can, so I'm going to stay away from that. Can I multiply this so it turns into a 3? No. Can I multiply this so it turns or cancels this? Yes. And so what I'm going to do is I'm going to multiply the top equation by the number 2. All right, and I'm going to rewrite it underneath here. Now, I could have recognized that I needed to change the sign, but this is a question that I commonly get. How do you know what to multiply by? I'm just going to work it out and show you. If you don't multiply by the right sign, you can still go to this step and make it work. So here I get now negative 2x plus 6y is equal to 16. Now, I can't add so they cancel, but if I change all the signs on one of these, they will cancel. So let's just do this. I'll make u positive, u doesn't matter for 0. I'll add these together. Those cancel. Notice that y is canceled in the first one, the x is canceled in the second one. And now I'm left with 8y equals to 16. Divide away the 8, and y is equal to 2. I like the second equation to plug into, so I'm going to use the second equation. I'm going to plug in my y value of 2. So here I have now 2x plus 2 times my y value equals 0. I get 2x plus 4 equals 0. Subtract the 4 to both sides. And now I'm left with 2x equals negative 4. Divide away the 2, and I get x equals negative 2. So my answer as an ordered pair is negative 2 comma 2. Alright, so I'm going to go ahead and hit pause. I'll be right back to start with the problems 3 and 4. I'm back. Alright, so let's move on to problems 3 and 4 for the practice test. And again, I'm using this flow chart to tell me how I need to proceed with these problems that we saw by elimination, or it's also called Gaussian elimination. Remember the story about Gauss, who taught us we can add the equations together as a 9-year-old. Alright, anyways, let's move on here. So I'm going to go through. Can I add these together and get somebody to cancel? No, this is not going to cancel. Close, I'm going to get minus 2y. So I'm going to move on to my second option, and that's going to be to subtract the equations. And remember, all that I have to do to subtract the equations is that I change all the signs. So if I change all the signs of the bottom equation, here I get 7x, here I get 0y. So that's going to be what I need to do. I'm going to proceed with the subtraction method. So I'm going to change all the signs of the bottom equation. I'm going to add them together. And I get 7x, oh, those cancel, equals 14. I'm going to divide out the 7, not the 7x, but the 7. And I get x equals to 2. I'm going to plug that into the first equation here. So I get 5 times 2 minus y equals 10. I get 10 minus y equals 10. Maybe that better than that. I'm going to subtract the 10 to both sides. And I get minus y, don't lose that, equals 0. Divide out the negative 1, y equals 0. Alright, so remember when you divide into nothing, you have nothing. So my ordered pair for this problem would be 2, comma, 0. Alright, let's move on to this fourth problem. And again, I'm going to go through the steps. Can I add them together and get someone to cancel? No and no. Can I change the signs and subtract? Nope and nope, because they're not the same numbers. Can I multiply one equation? Can I pick a number to multiply 3 so it becomes a 4? No. Can I do that with a 4 to become a 3? No. A 4 into a 6? No. A 6 into a 4? No. So now I need to multiply both equations. And so the way that I like to do this is I like to pick the variable that has a pair of smaller numbers, because I like working with smaller numbers. So I'm going to take the 4 from this equation and multiply everyone by that. And I'm going to take the 3 from this equation and multiply everyone down here by that. So my top equation is going to become 12x plus 16y. And that's equal to, I'm going to do some math here, negative 48. I'm going to take my second equation that I multiply by 3, and I'm going to rewrite it down here. So now I get negative 12x plus 18y. And that equals to, 3 times 18. So 2 18s is 36. One more 18 is 54, but it's negative 54. All right, so let's go ahead and now proceed with this. The x's cancel, and I'm left with 34y equals to negative 102. Let's divide out the 34. And we get y is equal to negative 3. I like the second or the first equation, the numbers are smaller. 3x plus 4 times negative 3 equals negative 12. (3x minus 12 equals negative 12). Add the 12. And we get 3x equals 0. Divide out the 3, then x is equal to 0. Remember, I need to write my solution as an ordered pair, x comma negative 3. 0 comma negative 3. 0 comma negative 3. There we go. All right, so I just wanted to go through how I would use this, and hopefully this helps some of you guys understand that there's a process to solving these, right? All right, so I'm going to go ahead and hit pause. I'm going to write problem 5 on the board and work that out, and then this will be the review for the Unit 5 quiz. I'm back. All right, so this is problem 5, but before I start, I just want to remind you a couple things. I made a chart here that tells you how we use the inequality symbols when we graph. If I have a less than or equal to or less than, I shade below. If I shade above, I have greater than or equal to or greater than. If I have either the less than or equal to or the greater than or equal to, I have a solid line, which means the answer is part of the line, the boundary. And if I have a less than or a greater than, I have a dashed line, which means the boundary line is not part of the solution. And remember, in inequalities, the solution is the shading. I wrote here y question mark mx plus b. It could be equal or any of these inequality symbols. But what matters for the graphing steps is that we begin on the y-axis, and the m, which is attached to the x, the m tells us how we move to the next point. And remember, m is rise over run, it's slope. And the solution is where the shading overlaps. So here are our two problems. Y is greater than 1/2 x plus 2, and y is less than negative 2x plus 1. You know, the very first thing I'm going to do is I'm going to put the negative with the 1. So I know that I'm going to rise in the down direction, right, in the negative direction. All right. So I'm going to do one in one color and then the other in another color, and where they overlap, that's my solution. So I'll do the first one in blue. So let's see here. I begin at 2. 1, 2. And I move down 1 and then right 2. So I begin at 2. I go down 1 and I go right 2. This is telling me that my line is dashed. And this is also telling me that I shade above. Okay, so let's move on to the second. Y is less than negative 2x minus 1. I'll do this one, and I hope that this shows up. I'll do it in purple. It might be too close to blue, but I hope that it's not. Now this number is missing a run number, and I can bring that back by just putting a 1 under it. So we begin at negative 1 on the y-axis, and from negative 1 I go down 2, right 1. So from negative 1 I go down 2, right 1. This is telling me my line is dashed, and I'm going to shade below. Way so you can see what I'm doing. And I'm going to shade below. I'll use a third color to show where the shading overlaps, because this is where my solutions are. Dashed, dashed, and in here. Any ordered pair and where the shading overlaps is the solution to this system of linear inequalities. that concludes our review for Unit 5, Quiz 1. Hopefully this makes sense and helps you guys do better in the test. I will see you guys later. Have a good day. Bye-bye.